Hello everyone, welcome to this video. We've been talking about continuous random variables, CRVs, and today we're going to look at how to find the center, in other words the mean, and the spread, in other words the variance. And from the variance you can find the standard deviation. So I'm going to give you those formulas today and show you how to use them. Because if you've got the PDF, everything is easy. If you've got the probability density function, life is great. So if f of x being your PDF, if that's equal to 0 everywhere except for AB, across that interval AB, then to find the mean, all you need to do, otherwise known as expected value of x, is integrate x f of x. And this is very similar to, if you remember how to find expected value of x for a discrete random variable, we just add up all of the x times the probability that x equals x. If you remember that from discrete, this is very similar. You add up all of the x times the function of x. And remember, the function of x gives you the probabilities. So it's very similar, just in a continuous format. So let's have a look at an example of how to do this. Okay, so example here, I'll just try to leave that there. Find the mean for this continuous random variable. We've been given the PDF f of x is equal to that. Okay. Now, just before we start, we've got an a here. Okay, and a is an unknown at this point, and we need to know that value of a to answer this question. So that's the first thing that we'll need to do. To determine that value of a, we need to apply what we always apply is that because it's a PDF, we know that the integral across the whole range will be equal to 1. So the integral from 1 to a of f of x, which is 1 over root x, dx, we know that that must be equal to 1. And we'll use this to solve for a. So we'll figure out what a is equal to. Okay, so I'll go downwards, I think, and I'll go across. So just to rewrite that, I'll always rewrite it in terms of powers. I just feel a lot more comfortable. X negative half. I can see it a lot easier when I write it like that. So that's equal to x to the negative half. So negative half goes up to 1 half. Divide by half, you get 2. It's between a. Gee, my a looks like a 9. Sorry about that. That's between a and 1. And that's equal to 1. Come up this way. Therefore, we've got 2 root a, subbing in a, minus 2 root 1 equals 1. Therefore, we have 2 root a minus 2. In fact, I'll just move that minus 2 over straight away, is equal to 1 plus 2, so that's 3. Therefore, a is equal to 3 over 2 squared, which will be 9 over 4. So a is equal to 9 over 4. So that's the first step. So now that we know a, we're good. Now that we know that, we can go in and use this formula above to find the mean, which is the expected value. Okay, so therefore, the mean, which is the expected value, you can write it either way, it doesn't matter. They mean the same thing. Mean the same thing. Is the integral between 1 and a in this case is 9 over 4. Now my 9 looks like an A. What an idiot, eh? Can't write properly. That looks worse, looks like a Q now. I'll leave it. That of x times f of x dx. Okay, so that's how we find the mean. Use all that space on here as well. Okay, so we'll integrate that. And so I'll just simplify before I do. 1, 9 over 4. And so that's x divided by root x. So that's x to the power 1 divided by x to the power half. That's just equal to x to the power half. So that's just x half dx. Let's see if I can squeeze this in. I've taken up too much space, but you'll see how I go. So x to the half. So x to the half goes up to 3 on 2. 3 on 2. And we divide by 3 on 2. So 2/3. Evaluated between 9 on 4. This is going to get horrible. And 1 is equal to, what did I pick this question to do? So it's equal to 2/3. 9 on 4. I'm going to need more space, definitely. 3 over 2. Take away 2/3. 1 to the 3 on 2. Okay, so let's have a think about this. Actually, that's not too bad. That's 2/3. Right, let's have a think about this. So 3 over 2, the power of 3 over 2, that means you square it and then you cube it. So the square root of 9 is 3, 3 cubed is 27, and square root of 4 is 2, 2 cubed is 8. It's actually going to be not too bad, minus 2/3, because 1 to the power of 3 over 2 is that. Will I be able to do this in time? I'll cancel out a couple of things here. That, and leaves a 4. And leave that, and leave a 9. So it's going to be 9 over 4. 9 over 4 minus 2/3, which is, let's put it all over 12. So that'll be 27 on 12 minus times 4, 8, which is 19 twelfths. So 19 twelfths is the average for that particular function. Okay, so the expected value that you expect to get if you're performing this experiment with that PDF function is 19 over 12. Hopefully that'll make sense. So that's the mean. Pardon me. The variance. If you remember the variance from discrete random variables, it's exactly the same. So the variance is equal to the expected value of x squared minus the expected value of x all squared. And that there just tells you, well, because you've got a continuous random variable, that's the expected value of x squared. You'll see the difference there. The expected value of x squared, you put an x squared instead of x. And this is what we already know as the expected value of x, and that's all squared. Okay, so I'm going to use CAS for this question, just to show you, because we don't know how to actually integrate this particular one. We don't know how to integrate log e in math methods. So let's have a look at this. So find the variance and standard deviation of that. Okay. So firstly, to be able to sort of work our way through, what we need first is ex squared. Okay, so ex squared is equal to, and that's going to be, in fact, should I just do it all in one go? If we got the CAS calculator, let's just do it, eh? Let's just do it. All right, let's say variance x, let's be brave, is equal to, so it's going to be the integral of x squared times by 2 log e to z. So that's the function, and we're going to be integrating that between half. So my writing's a bit small, e on 2. Too bad. So that's my x squared f of x dx, so that's that first part there. So I've sort of integrated between that and that. And so then we need to subtract. I'm going to put brackets. It's going to be horrible on the calculator. We'll see how we go. We'll see how we go, because everything's horrible here. Again, half to e on 2, and x f of x. And so it's just going to be 2x log e to x dx all squared. I'm just going to check that I've done that all right. That's yuck, yuck, yuck. So x squared, so it's going to be 2x squared log e. That all looks good. Oh, I forgot a dx there. Tell my students off for forgetting dx's. I know I've done it. And that looks good. All right, let's see if we can put this into the calculator. This is going to be yuck. But it'll give us, and we just need it correct to 4 decimal places, so at least we don't have to write any sort of exact horribleness. So because it's that, I'll just use decimals just to be typing a bit quicker. E over 2, I can't do that quickly though. E over 2. Do I have to put 1? No. I've never done that before. And then we got 2x squared and times natural log. Natural log of, have I changed to x's? Whoops, I've done some x's and some z's. I'm gonna, just so that you know, because I've written down at my, it should be in z's, it should be dz's, and that's the thing. I've accidentally changed to dx's, so I'll go with x's. So 2x squared log e 2x dx. Okay, so that's that first part. Take away bracket, because we're going to square the whole thing. Menu, calculus, integral, same thing. 0.5 I can just do E somewhere. Can I just do that? I'm just. That's it. So 2, and this one will be 2x log natural log. Didn't like that. Just put a times in between. Likes that better. Sometimes you have to just put times in between things. 2x dx, and it's this whole thing squared. Just double check I've done everything right there. 0.5 to e over 2. You can, it's so easy to make a mistake. 2x squared log e 2x dx. Yep, take away integral 0.5 to e over 2. 2x log e 2x. That all looks good to me. And did I get the squared right? Just want to make sure it looks good. Yep, that looks good. So my answer is the variance is, what did I want? 4 decimal places. So 0.0440 to 4 decimal places. Fantastic. So that's that. And to find the standard deviation, all I do is square the variance. And so that's just the square root of that. So square root of that. And we get to 4 decimal places as well. Yes, it does. So 0.2098. And there's my variance and standard deviation. So I hope that makes sense. So that's how we apply those two formulas to find the mean and variance. So in other words, the center and the spread. Hope that makes sense. I'll see you in the next video.